The gradient of a velocity time graph tells us acceleration, the rate of change of velocity, change in velocity per period of time that it took to make that change. All of these graphs have positive velocities. The man is going to move to the right in all cases. His velocity will be positive. In all cases, they are speeding up. They start at zero velocity, standing still, and get faster and faster. The difference between them, though, is the acceleration. The acceleration is low here, medium, and high. We can see that in the gradient of the graphs, because the gradient of a VT graph is acceleration. So here we have a shallow gradient, a low acceleration, medium, and a very high acceleration, a steep gradient. So let's observe them. Let's compare these three graphs. They all have positive velocities. So in all cases, the man is going to head to the right. His velocity is going to be positive. He's going to move in the positive direction. Another thing that's the same between the three graphs is that they all start fast and end standing still, zero velocity. So they all illustrate deceleration, getting slower. The difference between them is the gradients. All the gradients are negative because the acceleration is negative for all of them, but this is a shallower gradient, steeper and steepest, meaning that the acceleration here is low and greater and greatest. This is a very high acceleration. Because of that, although the velocity is going to change the same amount in each case, delta V is going to be the same for all three cases, but the time that it takes to make that change of velocity is going to be different. Here the velocity is going to take a long time to change from maximum to zero, here shorter, and here it's going to take a very short time for the velocity to change from maximum to zero. Let's watch. High acceleration, medium, low acceleration. In all cases, deceleration. So I could say high deceleration, medium, and low deceleration. But deceleration is a type of acceleration. So I'm not wrong to say that this was accelerating, even though it was actually decelerating, but decelerating is accelerating. Because accelerating means changing velocity. Decelerating is changing velocity to become slower. So all of them decelerated. This one decelerated very rapidly, and this one decelerated at a lower rate. How will the motion of the man differ in these three cases? What's the same and different between these three cases? In all three cases, the velocity is negative, so the man is going to be heading towards the left, moving negatively. In all three cases, he's going to be speeding up. He starts at zero velocity and gets faster and faster. But what's different between them is the gradient of the graph, the rate at which the velocity changes. We're going to observe for the same amount of time in all three cases. Here the gradient is shallow, steeper, steepest. The gradient of a velocity time graph tells us acceleration. This is going to be a low acceleration, greatest acceleration. So in this case, the rate of change of velocity is going to be great. So the velocity is going to change rapidly. Here, the velocity is going to change gradually. The acceleration is low. Let's observe. High acceleration, medium, low acceleration. All started at rest and picked up speed. They were speeding up and all were heading in the negative direction towards the left. In what way are these motions similar and different? In all cases, the velocity is negative. The motion is towards the negative direction, the left. In all cases, they start fast and end up standing still. Zero velocity. So they are all decelerating, slowing down. What is different between them? The acceleration, the gradient of the graph. Notice the gradient is positive. It's sloping upward. Although they are decelerating, they're getting slower and slower, the gradient, which tells us acceleration, is positive. The acceleration is positive, even though they are decelerating. Deceleration does not mean negative acceleration. Don't get that confused. Deceleration means getting slower, but this is positive acceleration, as you can see from the positive slope of the graph. That's the direction of the slope. Now let's speak about the magnitude of the slope. Here we have a shallow graph, steeper and steepest. Low acceleration, greatest acceleration. In other words, Here, the velocity will change very rapidly. It will only take a short time for the velocity to change from maximum to standing still. Here, the velocity is going to change gradually. The rate of change of velocity is low. The acceleration is low. So it's going to take a long time for the velocity to change from maximum to zero. Let's observe. High acceleration, medium, low. They are all decelerating, so I could say high deceleration, medium, low deceleration. Notice they were all heading to the left. Their velocity was negative in all cases.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!